It is said that the past is just a foreign country that you cannot visit. In this case, the reasons are not related to costs, travel documents, rejected visa applications, or problems with check-in. The big problem we can't get there is simply the laws of physics. However, an American scientist claims that this can be solved, and it is decided, according to CNN, to build a time machine. Astrophysicist Ron Mallett has dedicated most of his life to the idea of time travel. Now, at the age of 74, he claims to have discovered the equations and principles on which he will be able to build the first time machine. Mallett hopes that he will be able to turn the clock back so that he can embark on the journey of his life, building a time machine with which to travel to the past to see his father, who died of a heart attack when Ron was only 10 years old. For me, my father was the center of my universe, Mallett told CNN, recalling that a year after his father's death, he stumbled upon H.G. Wells. This book changed my life, said the astrophysicist. Ron Mallett is currently a professor of physics at the University of Connecticut. He has devoted his entire career to studying black holes and Einstein's theory of general relativity, which describes gravity as a property of space-time geometry, perceived as gravity, hurtling into the future at the impressive rate of 1 second per second. You're pretty much always moving through time at the same speed, whether you're watching paint dry or wishing you had more hours to visit with a friend from out of town. Although humans can't hop into a time machine and go back in time, we do know that clocks on airplanes and satellites travel at a different speed than those on Earth. We all travel in time. We travel 1 year in time between birthdays, for example. And we are all traveling in time at approximately the same speed, 1 second per second. NASA's space telescopes also give us a way to look back in time. Telescopes help us see stars and galaxies that are very far away. It takes a long time for the light from faraway galaxies to reach us. So, when we look into the sky with a telescope, we are seeing what those stars and galaxies looked like a very long time ago. However, when we think of the phrase time travel, we are usually thinking of traveling faster than 1 second per second. That kind of time travel sounds like something you'd only see in movies or science fiction books. Could it be real? Science says yes. More than 100 years ago, a famous scientist named Albert Einstein came up with an idea about how time works. He called it relativity. This theory says that time and space are linked together. Einstein also said our universe has a speed limit. Nothing can travel faster than the speed of light, 186,000 miles per second. What does this mean for time travel? Well, according to this theory, the faster you travel, the slower you experience time. Scientists have done some experiments to show that this is true. For example, there was an experiment that used 2 clocks set to the exact same time. One clock stayed on Earth, while the other flew in an airplane, going in the same direction Earth rotates. After the airplane flew around the world, scientists compared the 2 clocks. The clock on the fast-moving airplane was slightly behind the clock on the ground. So, the clock on the airplane was traveling slightly slower in time than 1 second per second. Einstein developed his theory of special relativity in 1905. Along with his later expansion, the theory of general relativity, it has become one of the foundational tenets of modern physics. Special relativity describes the relationship between space and time for objects moving at constant speeds in a straight line. While Einstein's theories appear to make time travel difficult, some researchers have proposed other solutions that could allow jumps back and forth in time. These alternate theories share one major flaw. As far as scientists can tell, there's no way a person could survive the kind of gravitational pulling and pushing that each solution requires. Again, this effect has been measured. In 2010, physicists at the U.S. National Institute of Standards and Technology, NIST, placed two atomic clocks on shelves, one 33 centimeters above the other, and measured the difference in their rate of ticking. The lower one ticked slower because it feels a slightly stronger gravity. To travel to the far future, all we need is a region of extremely strong gravity, such as a black hole. The closer you get to the event horizon, the slower time moves, but it's risky business. Cross the boundary, and you can never escape. As part of his theory, Einstein re-envisioned space itself. He coined the phrase spacetime, fusing the three dimensions of space and one dimension of time into a single term. Instead of treating space as a flat and rigid place that holds all the objects in the universe, Einstein thought of it as curved and malleable, able to form gravitational dips around masses that pull other objects in. Just as a bowling ball placed in the center of a trampoline would cause any smaller object placed on the trampoline to slide towards the center. Traveling at high speed isn't the only way to produce time dilation. Einstein showed that gravitational fields produce a similar effect, even the relatively weak field here on the surface of Earth. We don't notice it, because we spend all our lives here, but more than 12,400 miles, 20,000 kilometers, higher up gravity is measurably weaker and time passes more quickly, by about 45 microseconds per day. That's more significant than you might think, because it's the altitude at which GPS satellites orbit Earth, and their clocks need to be precisely synchronized with ground-based ones for the system to work properly. The satellites have to compensate for time dilation effects due both to their higher altitude and their faster speed. So whenever you use the GPS feature on your smartphone or your car's sat-nav, there's a tiny element of time travel involved. You and the satellites are traveling into the future at very slightly different rates. But for more dramatic effects, we need to look at much stronger gravitational fields, such as those around black holes, which can distort spacetime so much that it folds back on itself. The result is a so-called wormhole, a concept that's familiar from sci-fi movies, but actually originates in Einstein's theory of relativity. In effect, a wormhole is a shortcut from one point in spacetime to another. You enter one black hole and emerge from another one somewhere else. Unfortunately, it's not as practical a means of transport as the movies makes it look. That's because the black hole's gravity would tear you to pieces as you approached it, but it really is possible in theory. And because we're talking about spacetime, not just space, the wormhole's exit could be at an earlier time than its entrance. That means you would end up in the past rather than the future.